Visit parthakachana.com for technology resources and stock analysis. Here are 50 advanced-level Hadoop interview questions with corresponding answers designed for in-person interviews. Each question is followed by a detailed response to help viewers gain a thorough understanding of complex Hadoop concepts. 1. What are the key differences between Hadoop 1.x and Hadoop 2.x? Answer. In Hadoop 1.x, MapReduce is responsible for both resource management and job scheduling. Hadoop 2.x introduced YRN, yet another resource negotiator, as a separate layer to handle resource management, improving cluster utilization and scalability. Hadoop 2.x also supports multiple data processing models beyond MapReduce, such as Spark, Tez, and others. 2. How does YRN improve upon the limitations of the MapReduce framework? Answer. YARN decouples the resource management from the MapReduce framework, allowing better resource utilization. In YRN, resource management is handled by the resource manager, and job scheduling is managed by the application master. This separation of concerns improves scalability and supports workloads beyond MapReduce, such as real-time streaming. 3. What is speculative execution in Hadoop, and how does it affect performance? Answer. Speculative execution is a performance optimization feature in Hadoop, where slow-running tasks, stragglers, are detected and duplicated on other nodes. The job completes when any of the replicas finish. While it improves overall job execution time, it can lead to resource contention and inefficiency if not properly configured. 4. Explain the working of the Hadoop Distributed File System, HDFS, in ensuring data reliability. Answer. HDFS splits files into blocks and replicates each block to multiple data nodes, typically 3 by default. If one data node fails, the system automatically retrieves the data from another replica, ensuring high availability and fault tolerance. HDFS also uses heartbeat signals to monitor the health of data nodes. 5. What is the role of the secondary name node in Hadoop? Answer. The secondary name node is responsible for periodically merging the name node's edit log with the namespace image to prevent the edit log from growing too large. Contrary to popular belief, the secondary name node is not a backup of the name node, but a helper that reduces the burden on the name node. 6. How does Hadoop handle failures during MapReduce job execution? Answer. Hadoop automatically handles failures in several ways. If a task tracker fails, tasks running on it are rescheduled on another node. If the job tracker fails, the job is restarted. In case of a task failure, the task is retried on another node. After a certain number of retries, default is 4, the job fails. 7. Explain the purpose and working of the distributed cache in Hadoop. Answer. The distributed cache in Hadoop allows sharing files, like text, jars, archives, across the nodes in a cluster during job execution. These files are made available on local disks of data nodes, reducing the need to fetch the same file multiple times and improving job performance by speeding up access. 8. Can Hadoop clusters be deployed in cloud environments? What are the advantages and challenges? Answer. Yes, Hadoop clusters can be deployed in cloud environments like Amazon AWS, Google Cloud, and Microsoft Azure. Advantages include elastic scaling, pay-per-use cost models, and easy resource provisioning. Challenges involve network latency, security concerns, and data transfer costs when dealing with large datasets. 9. Describe how Hadoop achieves fault tolerance in a large cluster. Answer. Hadoop achieves fault tolerance through data replication and periodic heartbeat signals. Each file in HDFS is split into blocks, and each block is replicated to multiple data nodes. If a node goes down, the system can retrieve data from the replicas. Heartbeat signals help detect node failures and reassign tasks to healthy nodes. 10. How would you optimize a slow-running MapReduce job in a Hadoop cluster? Answer. Optimizations include tuning the number of mappers and reducers, using a combiner to reduce data transfer between mappers and reducers, enabling speculative execution for slow-running tasks, tuning block size and I/O settings, checking resource allocation in YRN to avoid contention. 11. How does Hadoop support multi-tenancy in a YRN-based environment? Answer. Yarn supports multi-tenancy by using resource queues with policies like FIFO, first in, first out, capacity scheduler, and fair scheduler. Each user or group can be assigned specific resource quotas, and jobs are scheduled based on available resources, while maintaining isolation between different users' workloads. 12. What are some challenges in managing metadata in a large Hadoop cluster, and how does Hadoop address them? Answer. Metadata in Hadoop is stored by the name node and can become a bottleneck in large clusters. Challenges include memory limitations and scalability issues. Hadoop addresses these through federation, multiple name nodes, and high availability (HA) configurations that allow for seamless failover and improved scalability. 13. Explain the difference between HDFS federation and high availability (HA) in Hadoop. Answer. HDFS federation allows multiple independent name nodes to manage different parts of the namespace, improving scalability by distributing metadata across multiple servers. High availability (HA), on the other hand, focuses on eliminating the name node as a single point of failure by providing a standby name node that can take over in case the primary fails. 14. What is the role of Zookeeper in a Hadoop cluster? Answer. Apache Zookeeper is used in Hadoop for coordinating and synchronizing distributed systems. In HDFS, Zookeeper helps manage the state of the name node in high availability setups, ensuring seamless failover by electing a new active name node when the current one fails. 15. Explain the concept of rack awareness in Hadoop and its significance. Answer. Rack awareness is a Hadoop feature that optimizes data placement based on the physical layout of the cluster. It ensures that replicas are distributed across different racks, minimizing data loss in case of a rack failure, and improving network bandwidth usage by reducing cross-rack traffic during data replication. 16. What is the significance of Apache Tez in the Hadoop ecosystem? Answer. Apache Tez is a DAG-based execution framework that improves upon the traditional MapReduce model by providing more flexible and efficient processing of data. It allows for complex data processing workflows with less overhead, better resource utilization, and faster job execution compared to MapReduce. 17. How does Hadoop handle small files, and why is it an issue? Answer. Small files are problematic in Hadoop because each file's metadata is stored in the name node's memory. When there are too many small files, it strains the name node's memory, leading to inefficiency. To mitigate this, Hadoop provides the Hadoop Archive (HAR) feature, which combines small files into larger archives, reducing the load on the name node. 18. How would you handle a situation where a large Hadoop job is failing due to insufficient memory? Answer. Increase the heap size for mappers and reducers using the MapReduce, map, memory.mb, and MapReduce, reduce, memory.mb configurations. Optimize the job by reducing data shuffling through a combiner. Adjust the number of tasks to distribute the load better. Consider increasing the number of nodes in the cluster. 19. Describe the process of a MapReduce job in Hadoop from submission to completion. Answer. When a job is submitted, the client submits the job configuration and JAR file to the job tracker, Hadoop1.x, or Resource Manager, YRN. Input data is split into blocks, and tasks, mappers, are assigned to process each block. Mappers output intermediate key-value pairs, which are shuffled and passed to reducers. Reducers generate the final output, which is written back to HDFS. 20. What is the difference between MapReduce and Apache Spark in the Hadoop ecosystem? Answer. MapReduce is a batch processing framework, while Spark is a more general-purpose data processing framework that supports in-memory processing, making it faster for iterative algorithms. Spark also provides APIs for different workloads like batch, streaming, and graph processing, whereas MapReduce is mainly limited to batch. 21. What are the primary use cases for Apache Hive in Hadoop, and how does it differ from traditional databases? Answer. Apache Hive is used for querying large datasets using SQL-like queries, HiveQL and Hadoop. Unlike traditional databases, Hive is designed for OLAP, online analytical processing, tasks rather than transactional workloads. It operates on top of HDFS and is optimized for reading and writing large volumes of data with batch processing capabilities. 22. What are the limitations of the Hadoop MapReduce model, and how can they be mitigated? Answer. Limitations include high latency due to disk I/O between map and reduce phases, poor support for iterative algorithms, lack of support for real-time processing. These can be mitigated by using frameworks like Apache Spark for in-memory processing, Tez for DAG-based workflows, or Flink for real-time streaming. 23. How does Apache HBase integrate with Hadoop, and what are its primary use cases? Answer. HBase is a distributed, NoSQL database that runs on top of HDFS. It allows real-time read/write access to large datasets, unlike Hadoop's batch processing model. Primary use cases include handling time series data, storing semi-structured data, and providing low-latency access for applications that need random reads and writes. 24. What is the significance of the shuffle phase in MapReduce, and how does it affect job performance? Answer. The shuffle phase in MapReduce transfers the intermediate key-value pairs produced by the mapper to the reducers. This phase can become a bottleneck due to network I/O and data movement between nodes. Job performance can be optimized by compressing intermediate data, using a combiner to reduce data, and tuning network settings for efficient data transfer. 25. Can you explain how security is handled in a Hadoop cluster? Answer. Hadoop security includes authentication, Kerberos, authorization through access control lists, and data encryption, SSL/TLS. Kerberos authenticates users and services, ensuring only authorized users can interact with Hadoop services. HDFS supports file permissions and encryption at rest, while network traffic can be encrypted using SSL/TLS. 26. How would you handle data skew in a Hadoop job, where one reducer is overwhelmed with more data than others? Answer. Data skew occurs when a single reducer receives more data than others. To address this, use a custom partitioner to ensure an even distribution of data. Break down large tasks or key groups into smaller ones. Adjust the number of reducers to better balance the workload. Avoid high cardinality keys if possible, and use a combiner to reduce the amount of data shuffled. 27. What is Apache Uzi, and how does it integrate with Hadoop? Answer. Apache Uzi is a workflow scheduler for managing Hadoop jobs. It allows the automation and coordination of various data processing tasks, MapReduce, Hive, Pig, etc., into a single workflow. Uzi integrates with YRN and can trigger jobs based on time or data availability, making it essential for building complex, multi-stage data pipelines. 28. What are some challenges in upgrading a Hadoop cluster, and how would you handle them? Answer. Challenges include ensuring compatibility of custom applications, avoiding downtime, and managing configuration changes. The upgrade process involves careful planning, testing in a staging environment, and leveraging Hadoop's rolling upgrade feature to minimize downtime. Back up critical data and test the new version thoroughly before migrating the entire cluster. 29. Explain how Hadoop's job prioritization works in a YRN cluster. Answer. Yarn supports job prioritization through its schedulers like Capacity Scheduler and Fair Scheduler. Capacity Scheduler allows setting resource quotas for different queues, where each queue can have a priority level. Fair Scheduler ensures fair resource allocation across jobs, with higher priority jobs getting resources faster while maintaining fairness for other jobs. 30. How does Apache Hadoop ensure data locality, and why is it important? Answer. Hadoop ensures data locality by scheduling tasks on nodes where the data resides, or as close as possible. This reduces the need to transfer large amounts of data over the network, improving performance. Data locality is essential in large clusters to minimize network congestion and increase job execution speed. 31. How would you configure Hadoop for processing a massive dataset that doesn't fit into memory? Answer. Hadoop is designed to handle large datasets that don't fit into memory. To optimize for such scenarios, adjust the block size and split settings to ensure efficient distribution of data across nodes. Tune the number of mappers and reducers to handle the load. Use Hadoop's built-in support for fault tolerance and data replication to manage data across the cluster. 32. What is Apache Pig, and when would you use it instead of traditional MapReduce? Answer. Apache Pig is a high-level platform for creating MapReduce programs using a scripting language, Pig Latin. Pig simplifies the process of writing complex MapReduce jobs by providing data flow primitives, making it easier for non-developers to work with large datasets. It's typically used for data transformation tasks, ETL, extract, transform, load, operations, and when fast prototyping is needed. 33. How does Hadoop S-Combiner function work, and when should you use it? Answer. The combiner function acts as a mini-reducer that runs during the map phase to reduce the volume of data that needs to be transferred across the network to the reducers. Combiners are most effective when the reduce operation is associative and commutative, e.g., summing values. It should be used when the intermediate data is too large and can be compressed before the shuffle. 34. How would you debug a failed Hadoop job? Answer. To debug a failed Hadoop job, start by examining the job slog files, specifically the MapReduce framework logs. Look for common issues like out-of-memory errors, incorrect input paths, or network failures. Use Hadoop S built-in counters to identify bottlenecks or misconfigurations. If needed, enable more verbose logging and rerun the job in a smaller test environment for further debugging. 35. What is the purpose of the FAIR scheduler in Hadoop? How does it differ from the capacity scheduler? Answer. The FAIR scheduler allocates resources to jobs such that all jobs get an equal share of resources over time. It allows more jobs to run simultaneously and improves resource utilization. The capacity scheduler, on the other hand, is based on setting quotas for different users or groups. FAIR scheduler focuses on fairness, while capacity scheduler emphasizes capacity guarantees. 36. How does Apache Hadoop handle schema evolution in data formats like Avro or Parquet? Answer. Hadoop supports schema evolution in Avro and Parquet by allowing changes in data structure over time. In Avro, for example, new fields can be added to the schema or fields can be removed. As long as the new schema is compatible with the old schema, e.g., new fields have default values, Hadoop can read both new and old records without issues. 37. How does Hadoop handle large-scale graph processing, and which tools can be used for this purpose? Answer. Hadoop is not optimized for graph processing in its native MapReduce form, but tools like Apache Giraffe and GraphX, part of Apache Spark, are designed for large-scale graph processing on Hadoop clusters. These tools provide specialized algorithms and data structures for graph traversal and manipulation, enabling efficient computation on large graphs. 38. Explain how you would configure Hadoop for high availability, HA, in a production environment. Answer. High availability, HA, in Hadoop involves setting up two name nodes in an active standby configuration. This is done using shared storage like an NFS mount or QGM to store the metadata. Zookeeper is used to handle failover between the active and standby name nodes. HDFS client requests are redirected to the active name node, and in case of failure, Zookeeper automatically promotes the standby name node. 39. What is the purpose of the Hadoop schedulers, and which ones are commonly used? Answer. Hadoop schedulers are used to allocate resources to different jobs in a YRN cluster. The most common schedulers are FIFO, first in first out jobs are processed in the order they are submitted. Capacity scheduler allocates resources based on predefined quotas, ensuring that each queue receives a fair share of resources. Fair scheduler ensures that each job gets an equal share of resources over time, allowing smaller jobs to finish quickly even if larger jobs are running. 40. How does Hadoop manage node failures in a YRN-based cluster? Answer. Hadoop manages node failures by using heartbeat signals to monitor the status of nodes in the cluster. If a node fails to send a heartbeat signal within a specified time frame, Yarn marks the node as dead and reassigns tasks that were running on that node to other healthy nodes. Data replication in HDFS ensures that data is still available even if a data node fails. 41. What are the challenges of running Hadoop on a multi-tenant cluster, and how can you mitigate them? Answer. Challenges include resource contention, job prioritization, and ensuring fair access to resources. Mitigation strategies involve using schedulers like Fair Scheduler or Capacity Scheduler to allocate resources based on user priorities, implementing quotas and isolating workloads through YRN containers to prevent interference between tenants. 42. What is Apache Flume, and how does it complement Hadoop? Answer. Apache Flume is a distributed service for efficiently collecting, aggregating, and moving large amounts of log data to Hadoop. It complements Hadoop by providing a reliable mechanism for ingesting data from multiple sources, like log files, network streams, into HDFS for processing and analysis. 43. How would you secure a Hadoop cluster that stores sensitive data? Answer. To secure a Hadoop cluster, implement Kerberos for authentication. Use HDFS file permissions to control access to files and directories. Enable HDFS encryption for sensitive data at rest, and use SSL/TLS for data in transit. Regularly audit logs for suspicious activity and enforce strict access controls at the user and service level. 44. What is the difference between Apache HBase and HDFS? Answer. HBase is a NoSQL database built on top of HDFS that provides real-time read and write access to large datasets, while HDFS is a distributed file system optimized for batch processing of large datasets. HBase supports random access and is used for OLTP, online transaction processing, workloads, while HDFS is used for OLAP, online analytical processing, workloads. 45. How would you optimize a slow-running Hive query in Hadoop? Answer. To optimize a slow-running Hive query, use partitioning and bucketing to minimize the amount of data scanned. Enable Tez or Spark as the execution engine for better performance. Optimize joins by using map-side joins or choosing the right join type. Tune the number of mappers and reducers and adjust memory settings in YRN to improve resource allocation. 46. What is speculative execution in Hadoop, and how does it improve performance? Answer. Speculative execution is a feature in Hadoop where duplicate tasks are launched for slow-running tasks to avoid bottlenecks. The first task to finish is accepted, and the other is killed. This improves overall job performance by ensuring that slow or straggling tasks do not delay the entire job. 47. How would you configure Hadoop to ensure efficient resource utilization in a YRN cluster? Answer. Efficient resource utilization in YRN involves tuning the memory and CPU settings for each container based on the workload. Using a scheduler like Capacity Scheduler or Fair Scheduler to allocate resources based on job priority and queue quotas. Setting up preemption policies to reclaim resources from low-priority jobs if needed. Monitoring resource usage with YRN S Resource Manager and Node Manager to identify bottlenecks. 48. What are the advantages and disadvantages of using HDFS Federation? Answer. Advantages. Scales the name node by allowing multiple namespaces, reducing the load on a single name node. Enables more efficient use of cluster resources by isolating different datasets into separate namespaces. Disadvantages. Increases operational complexity as multiple name nodes need to be managed. Certain cross-namespace operations become more challenging to implement. 49. How does Hadoop handle data consistency during write operations, especially in scenarios involving multiple clients writing to the same file? Answer. Hadoop ensures data consistency during write operations through its append-only model in HDFS. In HDFS, once a file is created and closed, it cannot be modified, except for appending more data. When a client writes to a file, the write lock is applied to the file, preventing other clients from making changes until the operation is completed. This guarantees that only one client can write to a file at a time, ensuring data consistency. In case multiple clients attempt to write to the same file simultaneously, the first client to initiate the write operation gets exclusive access to the file. Any other clients attempting to write will receive an error until the file is closed. This approach avoids conflicts or corruption in the file. Moreover, Hadoop uses data replication to ensure fault tolerance. As data is written, it's simultaneously replicated to multiple data nodes according to the configured replication factor. This ensures that in case one data node fails during a write operation, the data can still be retrieved and written to a healthy data node, maintaining consistency. However, HDFS does not support concurrent writes or modifications by multiple clients. If use cases require concurrent data access or transactional guarantees, frameworks like Apache HBase, which runs on top of HDFS, provide mechanisms for handling such scenarios, offering finer control over consistency, with features like region locking and atomic operations. 50. What is YRN Capacity Scheduler, and how would you configure it for multi-tenant workloads? Answer. The YRN Capacity Scheduler allows resource allocation by dividing cluster resources into different queues with pre-configured capacities. To configure it for multi-tenant workloads, create separate queues for each tenant and set appropriate capacity limits. Enforce user limits to prevent any single user from monopolizing resources. Configure preemption to reclaim resources from overutilized queues for higher priority tasks. Adjust queue configurations dynamically as workloads change to maintain optimal cluster utilization. Thank you for watching. Like, share, and subscribe. Visit parthakachana.com for technology resources and stock analysis.